I see. Attendance. All right, everybody, welcome back. Welcome back. Can everybody hear me?
Yes.
Yes. Wonderful, wonderful. Welcome back. Welcome back. All right, let's quickly start with attendance. Here we go. Abby.
Here.
Nice. Laura. As people are coming in. Laura? No Laura? Okay. Absent. Laura's here? Yes, no, yes, no. Okay. Deidre?
Here.
All right. Ashley. I thought I saw Ashley. I do see Ashley on the list here. Text me in the chat if like somehow you're having issues with your audio or something, and be like, I'm here, okay? Ashley. Oh, I said Ashley. Paulina.
Here.
Awesome. Akili.
Here.
Nice. Liam.
Hello there.
Nice. Emily.
Here.
Heather.
Here.
Yerin. Oh, Yerin. Savannah. No Savannah. I don't see anything in the chat. Okay. Carrie.
Here.
Okay. James Lynn.
Here.
Nice. Amanda.
Here.
Steffi.
Here.
Nice. Christina.
Here.
Nice. Naja.
Here.
Okay. Morgan.
Here.
Nice. Gianna.
Here.
Good. Apurva. Hello? No? No? Okay. I think I see Apurva. Emma?
Here.
Okay. Samantha?
Here.
Great. Jenny?
Here.
I think I saw that, Jenny. Joy?
Here.
Awesome. And then Tengwei?
Here.
Awesome.
Can you hear me?
Yes, Savannah, I can hear you. Tengwei, you go by Alexis, right?
Yes.
Okay, sorry. Yes, I remember that. All right. Okay, I think I got everybody except, do we have Apurva? Just came in, maybe? Oh, and then Savannah's here. Good, I see Savannah. And then last but not least, Laura. You see Laura? Okay, so we don't see last call for Laura and Apurva. No? Okay, I'm submitting attendance, guys. All right, great. Okay, so welcome back. Oh, of course, there's an error in Blackboard. We'll see if that got submitted. Okay, so welcome back. Let's start off by doing a little bit of a review from last time. So we only covered population versus sample, right? So why don't, I'm gonna, in the chat, I'm gonna send you guys a Google Slides link. Everybody go here. And let's see, I'll go in there and see if you guys can actually access it. Let's do a little sample problem to see if we remember what we learned last time. Can you guys access it?
It wants us to request access.
Yeah.
Oh, I just made it a public access. Why is this doing to me? Oh, is it because it's a Google Drive thing?
I think you could share your screen.
I know, but I wanted you guys to type it in and, you know, make it interactive. Anyone with a link? Is this because it's a Google? But I didn't make it into a Google permission updated. Okay, copy link. All right, let me just try it one more time. Let's see if it works or
I
works.
got it. I think.
Wait. Yeah.
Yeah, mine just did it too.
Oh, okay. You know what? Because I just changed the permission. But I changed the permission before. Anyways, okay, get in. Okay, here we go. All kinds of animals. Here we go. Here we go. Great, 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 great. Okay. All right. Nice. Okay. Morgan, can you read the example for us? It's on slide 2.
Yeah, let me get the split screen. Okay. Example. An NYC food Instagram influencer posted a poll about the best pizza places. After a heated debate, the influencer asked his/her NYC followers to call a number and say the name of which restaurant they thought had the best pizza. Charge of $1 per vote. It turned out that 68% of callers agreed with the influencer's choice.
Okay, so if this is the situation, guys, I want you guys to identify what the population is and what the sample is. So what you guys are going to do, there should be 25 plus slides. Go claim a slide. Every slide has a click to add title. Go claim a slide and put your name in there, okay? And then you're going to answer those questions individually, okay? So make sure you're not in the same slide. Just go towards some other random slide. And once you put a name on it, that slide is yours, okay? So go ahead and answer what the population of interest is and what the sample is.
It's a view only.
Yeah,
we
it's
can't
only.
edit it.
I am just gonna die today. I've been teaching since 9 a.m. I'm like, my throat is about to get. Anyone on the internet with this link can view. Oh, no. To edit. Done. Okay, refresh. Permission has been updated. Now you can type in. Can you type in now? Okay, good.
Yes.
Little setback. Let's go back into Blackboard. Oh, Blackboard fails me today. I'm gonna lose it. 222. Okay, what is the population of interest and what is the sample? 302. Remember, if you just joined me remember, I already took attendance, so you have to message me or email me so you're not marked as absent, in case that's your situation right now.
Hi, Professor. I'm sorry. I just
Oh,
I knew.
all right. Let me update that. You're gonna go, do you see the chat? If you come in late, I'm not sure if you can see it. Go to this document and you're gonna claim a slide, put your name on the top, and then answer the 2 questions. Which one is the population of interest and which one is the sample?
Got it.
Okay, and then I am going to make sure I go to attendance and not mark you.
My slide is still on view only. I'm not able to edit.
Can you refresh your page? So you can refresh on the browser, or you can do, if you're like a Mac, Command-Shift-R. Because permission's been updated, so it might have just been that you haven't gotten to the latest version. Okay, attendance record. What's step 2? All right, we all answered. Let's see what we got here. All right, so let's see. I'll pick, like, scroll down and pick randomly. Let's see what we have here. We got, all right, I'm on Emily's slide. The population of interest that you said all the influencers followers, right? Influencer apostrophe followers. And then what is the sample? 68% who answered. Do we agree?
Yes.
Yes. So the people who are following the pizza influencer guy is the population. I'm going through influencer followers, very good. So people who have wrote New York City people or New York City as a whole population, that is not true, right? You gotta be very specific. The population is always the group that we're interested in, right? So if you go back to the slide 2, he is asking his or her New York City influencer New York City followers to call a number. So that's the population we're dealing with. Not everybody in New York City. Sorry. I'm here. I keep turning the light on in my office. It keeps turning off. Thinks I'm dead. All right. So instead of saying the entire New York City population or everybody in New York, you have to be more specific and say the influencers, New York City followers, okay? So make that adjustment in each of your slides. And I think we're all agreeing with—
Could you define the population one more time? You said is the group, like the population is the group that
we are looking into. So usually when we're doing some kind of study or there's like a research question, the population is the entire population that we are interested in, right? So it's usually going to be from the question you are asked, it's going to be in that context. Okay, so that's a great question, Morgan. So let me go ahead and share my screen. And so let's go back to our chapter in population. And that's 4.1. The population, what you want to know about. That's a very easy way to look at it, right? We want to know about. So the example in the particular slide that we did, it didn't say all we want to hear from all the people in New York City. It didn't say that, right? It didn't say that we want to hear from all the people in the United States. It said that he wanted to, or he or she wanted to ask his New York City followers. That's what we want to know about, and therefore that is the population. And among those people, 68% of them responded. So that will be our sample. Okay. All right. Excellent. Okay. So if you go to Blackboard and if you go to content, and I will share my screen to show you guys this. If you go to content, the top one is class recordings. If you go to intro to statistics, and then you go to mod 1 questions assignment. So this is something that hopefully we have some time to start. but you're going to go into this like I'm doing right now. And I'm the creator of this, so it's not going to have that. But when you guys go into it, somewhere around here, I think at the top, it'll say viewer or only viewing, okay? So what you guys are going to do is go to file, and then you're going to make a copy. And once you do that, it will say something like copy of mod 1 questions. Maybe you want to title it differently, like MA222, module 1, or whatever, and maybe put it in a particular folder. I have a separate MA222 folder. So that's where you're going to make sure and you make a copy of it. And then once you make a copy, you'll have, you can actually put in answers in the edit. You'll have editing privileges, right? So this is the situation. And then in here, like right next to A, in column B, you're going to identify what the population is. And you're going to identify the sample size, okay? And then answer these questions. And remember that there is X1, X2, and X3, okay? As in like example 1, example 2, and example 3, okay? So that's what you're going to finish, hopefully by today, or if not, by the end of the week, okay? So that's to give you some more practice on population versus sample. Under, in this one, like number 1, Introduction to Statistics, you will see Mod 1 spreadsheet tutorial. This will help you kind of give you an introduction to how spreadsheets work. Okay, so I would highly recommend that you kind of take a look at this. We're going to be using different formulas and stuff like that in Google Spreadsheet. So becoming familiar with this would be very, very helpful for you guys as well. Okay, so that's available for you guys. And then Mod 1 spreadsheet assignments, you go to that one. This is just a introduction to how you can make a copy and what I'm expecting you, how to share it with me, et cetera, et cetera. So those are instructions as well. So you can quickly gloss over those, okay? And then today, our new topic, we're going to start from descriptive and inferential statistics. So in one, Introduction to Statistics, you can like click on the second link, or if you're already in the chapter like I am, you can just go to chapter 3 to descriptive and inferential statistics. Okay, so we'll start from here. All right, let's see. Naja, can you start us off right here? Read this paragraph for us.
There are two main approaches in statistics. One focuses on presenting a situation and the other is about predicting. You may notice we like to offer ways to remember concepts, so here's one. So here's another one. D with D and I with I, descriptive statistics deals with describing data, while inferential statistics is used to infer.
Very good, right? So this is it's not very complicated, right? Describing something is descriptive. And then if we actually infer, we draw conclusions for it, then we call it inferential statistics, okay? Descriptive statistics. Next one, Ashley, could you please read this part? We have Ashley? No? Actually, James Lynn, do you want to go? Your mic is already off.
Yeah, I'll read it.
Okay.
Okay, statistics techniques used mainly for summarizing data are called descriptive statistics. So in descriptive statistics, the goal is to describe a situation. We want accurate information and then let others know about this data. Descriptive statistics involve collecting data, organizing data, summarizing data, and presenting data. There are different ways to present data, including charts and tables. It can also be powerful for a summary to be just numerical value. For example, April 2020 headlines mention U.S. unemployment claims were about 17 million people in 3 weeks.
Right? Basically summarizing what is, right? Descriptive. It's describing something's going on, okay? So inferential statistics. Deidre, can you start us off?
Statistical techniques used primarily to draw conclusions about populations are called inferential statistics. An inference is a decision based on samples drawn from populations. Inferential statistics uses probability, which is the chance of an event occurring. For example, the Congressional Budget Office expects the unemployment rate will be 9% at the end of 2021. Can you tell why this is an inference rather than a description? We are currently in 2020, so referring to a year in the future is a good indicator we have inferential information. The words will be instead of are can also be a tip-off we are dealing with an inferential statement. Note, we will try to use other examples, but with the pandemic going on, it is difficult.
Yeah, I don't really know. I mean, we can use a lot of examples. I guess pandemic make it difficult? No. So let me just show you this, guys. I don't have my screen. Do I have my screen shared, right, guys? Okay, yes, I think I do. So let's start describing. About 10% of people are left-handed. Descriptive, inferential. You can do me or I in the chat or just shout it out.
Inferential.
Descriptive.
Descriptive. We're not inferring anything. We are just stating what's there. We're describing and we're summarizing. Okay, so about 10% of the people are left-handed. We're not drawing any conclusions from that, okay? All right, maybe a little bit more practice. Next one. Drinking bubble tea can lower cholesterol levels by 1%.
Descriptive.
Descriptive.
Inferential.
I thought it was inferential.
This would be inferential, okay? By the way, I don't know if this is true. Actually, one of the authors of this book is really obsessed with bubble tea, so I think she wants to believe that. I don't know if that's true, so don't take it. It could. I don't know. Black tea could be good for you. I'm not really sure. But this is can lower cholesterol. We're not really sure if it can or it will or it won't. You know, this is making an inference. This is drawing a conclusion, okay? So this is not just summarizing what is there. So in this case, it will be inferential, okay? All right, let's try a few more. 9 out of 10 students in a certain major use Instagram. D or I?
I. No.
D.
D.
D will be the right answer, right? It's describing what is happening, summarizing a phenomenon, okay? Not making any conclusions of it. That's just right now what it is, okay? 9 out of 10 students in a certain major use Instagram. All right, so a few more. According to a census, the US median household income is about this. D or I?
D.
D. Very good. Descriptive, right? According to that census data, this is the median. Okay? Just stating what is, summarizing. Okay, next. That many prospective students applied to the Harvard class of 2024.
D.
C.
D.
Very good, right? Describing what is, just summarizing what's happening. Very good. Okay. In the year 2030, about this courses will be offered at FIT.
I.
I. Very good, right? This hasn't happened yet. We are, based on whatever it is, we are making kind of an inference about what could be happening or what will happen. All right? Okay, so that's the idea. It could get a little bit confusing, right? But these were the examples that were here that is in 3.3. So if you want to review it, you can go back to those things, okay? So again, just to emphasize, descriptive deals with describing data, and inferential is for inferring, which is why it's inferential, right? Describing a situation, summarizing a data is all about descriptive. And then inferential statistics is all about drawing conclusions about populations, okay? So that's the distinction you want to make. All right, there'll be in the Google spreadsheets, there'll be more examples for you to practice on, okay? But it looks like toward the end, you guys were getting the idea, okay? So more about inferential one, which might be a little bit more confusing. Okay, Akili, can you read this part right here?
Let's look more at inferential statistics. We take data values, called the sample, to make inferences, draw conclusions about an entire group we're interested in, called the population. After we analyze collected sample data, we reach a conclusion.
Very good. This example, Abby, can you read this for us?
Based on a random sample of 100 females 18 years or older in New York City, we believe that the average height of all females 18 years or older in New York City is 64 inches with a maximum error of 3 inches. We are 90% confident of this.
Okay, all right. Christina, next paragraph, please.
Here we are using the data values from our sample, the 100 New York City females, to estimate the average height of the entire population of females in New York City. We get this estimate by doing a calculation based on the data values from the sample. It should be mentioned that we do not find out the height of every single female 18 or older in New York City. Rather, we can only estimate the average and talk about how certain we are of our estimate. Again, we draw conclusions about a certain population based on our specific sample.
Right? So when we're drawing conclusions, that's when you want to think inferential. Okay, let's do a few more examples about this. All right, so let's see. All right. The average life expectancy in the Netherlands is 81.6 years. What do you guys think?
D.
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 Yes, I believe so. I had a moment of scarce there, right? Yes, very good. Okay. Average life expectancy is D, descriptive. Okay. A diet high in potassium will lower blood pressure. D or I?
I.
I.
Right? We're making some kind of conclusion about that. Another one. Total amount of money a household spent on bubble tea in 1 week was $35.40. You don't really need to read this part.
That's D.
D, right? That is how it is, the summary of it. And the author actually confessed that really it's her drinking it, but nobody else in the family drinks it. She's really obsessed. We talk about this like extensively through text. We always tell each other which new place we tried. All right. I stopped drinking bubble tea for a while though. I don't know why. All right. In 2033, the number of high school students will be 3.6 million.
I.
Very good. Will be. Okay. So
What if the word will be is not in there? Like what other word would possibly be in there to still make it I?
2033, because it's kind of in the future. Because we don't really, we can't summarize the future like what is, right? Because that hasn't happened.
Okay.
That will be another. Yeah.
Okay.
So this is like there's no thing here. There's no year, but then it says the number of high school students are or is. Then you know that's a descriptive statement.
And they're making this inference based off of other like descriptive statistics.
It could be a number of things, right? It could be the actual data they have in something like a diet high in potassium. This would be something maybe they ran a study with a sample of people and they saw and they drew a conclusion based on this. People with a lot of potassium 5 years later had lower blood pressure than the people who had low potassium diets, right? So it could be based on a research study. But yes, in that particular case, that research study's analysis and results, well, depending on how you frame it, but it is a lot of descriptive statistics they're basing that off on.
So if we were to change this statement, a diet high in potassium does lower blood pressure, would that then be D? Because it's
diet high in potassium does lower blood pressure. I believe so. It's a little, I'm going to say yes to that. The reason why I'm saying a little bit with hesitation is because yes is a good answer for that. Yeah. Because it's summarizing something, right? I don't know if it's true, but
it's
it
for
is
sure and like factual. Like it does.
That's why I didn't say the word factual actually, because it might not be true, right? But it is summarizing something, right?
Okay.
So it is possible that a diet high in potassium does not lower blood pressure. But if it does say a diet high in potassium does lower blood pressure, whether it's factual or not, it's still summarizing something, which means that is descriptive. Yes.
Okay.
But that's an excellent question, Morgan. Excellent question. Yes. Very, very good. Right? So whether something is true or not, fact checking and all that, that's a little bit different, right? And even when it comes to inferential statistics, you guys should always be aware that somebody's still making some kind of conclusion. So there could be bias in it. It could be making the wrong conclusion. So this is not about whether something's wrong or right or factual or not factual. This is just kind of whether something describing something or if something being inferred. Okay, that's a great question though, okay? And we will talk about at some point, I think in about a week or two, about the misuses of statistics and misleading things, right? It could be very, very much, statistics can be used in a very bad way to mislead people. It's done all the time in elections and advertising. This is done a lot. So that's why we need to have a critical eye, okay? Very good. So descriptive versus inferential. Definitely think about those things, and you'll have more opportunities to practice. All right, let's move on to now. So we did chapter 4 in the book. So let's go to parameter chapter 5, parameter and statistic. I'm going to go through these chapters a little bit quickly today so that we leave quite some enough time to work on Google spreadsheets and the in-class activity together, okay? These concepts are obviously very new, and you guys are going to take some time to get used to it, just like the descriptive versus inferential, but that's fine. All of these, the material is still going to be online. The next time you look at it, it's going to be more familiar. The third time you look at it, it's going to be more familiar, okay? So for now, we're just getting acquainted, just starting to learn about these definitions. All right, so chapter 5, let me go resume my screen share. All right, Gianna, can you start us off with this particular chapter 5 right here, where I highlighted?
Yeah, sure. Next, we define the term parameter and statistics. These go hand in hand with population and sample. Parameter is a number that describes property of the population. A parameter is a number we are interested in knowing about the population. We've already seen one example. A population mean is an example of a parameter.
Very good. How do you read this guy? Who remembers?
Mu.
Mu. Very good. Very good, Christina, right? Mu. Okay, it's a Greek symbol when we talk about population, right? That's one of the symbols that we learned last week. Okay, so when we talk about parameter, we're talking about population. How is that good? Well, it's P and it's P. So that's how we're going to memorize it, right? Anything that has to do with a population, we're dealing with parameter. And therefore, mu represents the population average, the population mean. So that means we're dealing with a parameter, okay? Parameters are computed by using all the data in the population. Again, from last week, are we more likely to be dealing with population data or sample data in real life?
Sample.
Sample data, right? It is almost rarely possible to collect entire data sets for a population, right? For practical reasons. All right, very good. All right. And so that's why I say parameters, we almost never have exactly, right? Just not very possible. All right, statistic is the one we're going to go next. Paulina, could you start us off?
Yeah. A statistic is a number that describes the same property as above, but it's computed from the sample. A statistic is a number we're interested in, but it comes from using only data in the sample, not the whole population. We have already seen one example. Sample mean X bar is an example of a statistic.
Very good. I was going to ask the whole class how you read that, but Paulina did it for us, right? X bar. Remember, this one was the symbol that we used to calculate the sample average or the sample mean. Very, very good. So statistics is for sample. So it's really kind of nice because population with parameter, P and P, and then statistic with sample, S and S. So that's how you're going to kind of remember that, right? Anything that has to do with a sample, we are dealing with statistics. This is why the whole field of statistics, as I told you, we never really get to use population data. That's why it's statistics, because we are doing statistical stuff, which is usually based off of the sample of a population, okay? So here the sample mean uses just the data values in the sample and computes the mean from just the data. And then this is where the tip is, right? P with P and S with S. So you can kind of easily remember that. You will be probably familiar, although we get like, it's a lot of a little bit of a tongue twister, statistical analysis, right? Kind of becomes a tongue twister a little bit, but we have heard of this probably word a lot with reports. And that makes sense, right? Because with every report that basically exists in this world, we're going to deal with a sample. And anything that has to do with a sample is going to be a statistic. That's why we have seen these reports all over about statistics of this, the statistics of that, right? The statistics of the US college students, the statistics of the admission process of that, blah, 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 right? Statistics are definitely easier to compute. All right, so let's kind of identify a few things, right? Suppose we wished, I'm going to try to not open it up, but you guys all have the access to it, right? Suppose we wish to estimate the mean amount spent on clothes. Oh, this is the same thing that we had before, right? For the women over 18 in Long Island. We sent out 100 emails. As a result, we take the mean, so the average of 34 responses that we got, and the sample mean was 2,100. Okay, so what is the parameter, guys? Who can guess? What is the parameter and what is the statistic? Anybody?
Is the parameter Long Island?
So, okay. So we gotta make two distinctions here, and this is a very confusing concept. We have population and sample, and then we have parameter and statistic. So when you're talking about parameter and statistics, we're always going to be talking about numbers. When we talk about population and sample, we're talking about kind of like groups of things or people. So to follow up with that, the population for this will be not just Long Island, right? But it's the women over the age of 18 living in Long Island, right? That's the entire population.
Oh, okay.
And the sample was the 34 women who responded to the, emails, right? So that's, yes.
So there is a parameter.
So is the 100 emails, yeah, the parameter?
No, remember, so the, oh, I see, parameter. So the parameter is not quite, remember, it's never about what we're trying to collect. It's the actual collection. Well,
I thought that was a sample.
So that was a sample, but this is the number that's related to that. So the number that's related to the population is what? It's not 100, right?
Is it the 18 living in Long Island?
Right. So it is the average, what is it? Amount spent on clothes for all the women living in, over 18 living in Long Island. That would be the parameter.
Okay.
So then what is the statistic?
It's
34.
the sample mean.
The
The
sample mean.
2,100.
Yeah.
Very good. Okay. So the distinction here, this is really good, guys. This is really good. So what you're thinking is we're getting the population and sample a little bit confused with the parameter and statistic. So population and sample, kind of think of it as defining a group of people or a group of things, right? Numbers are not involved. But when we're talking about parameter and statistic, now we're talking about numbers here. And in this particular example, we're talking about the mean, the average. Okay, so the parameter is going to be an average of something, and the statistic is also going to be the average of something. But the parameter is going to deal with a population, and the statistic is going to be with a sample. But they're both going to be talking about means. When it comes to population and sample, we're talking about the people that we're dealing here. Okay, so if you read right above, so remember, population is this people, that group of people. But the parameter is the mean amount of this population.
So even if we don't get anything from it, that's still what the like parameter is. Like it has nothing to do with the numbers we got, nothing to do with the number of emails we sent out.
Correct.
Correct.
Okay. Correct. If you did send out the emails to every single living soul, living woman over 18 living in Long Island, then that would be helping you with a parameter. Okay. Yes. Yes. And even though it's not given to you, the population mean is not available as the information in this little text, that doesn't mean that the definition of the parameter changes, right? It's still the mean, the average of all the women living in Long Island over 18 and their mean amount spent on clothing. This technically should say all women over 18 living in Long Island to be more technically correct. but this is a pretty close answer, okay? So that will be the mu. Again, we don't know this value right now. And most of the times, as we said just before, we don't really know any of the population stuff. We don't know the population data. We don't have the population data, and definitely we do not have access to the parameter, like some kind of mean of the population. We do, however, have the sample mean, which will be the statistic in this case. Okay, so those are the two kind of big concepts we need to distinguish. Very good, guys, very good. And then remember, we use X bar to denote this. X bar equals 2100. Usually you will take off the $sign, right? We're just dealing with numbers right here. Okay. All right, so again, population mean parameter goes here, and then sample mean we are calling it's the statistic. Hopefully the statistic will allow us to estimate the parameter, right? Again, the sample is what we have access to, so unfortunately we are going to kind of take a look at the sample, do some inferential statistics, like draw some conclusions, and we kind of say, well, this is probably what the population is like. Hopefully, assuming that the sample actually does represent the population. That's not always going to be the case, right? There's going to be biases, and maybe it's not randomly selected, and so maybe it's skewed in one direction, which we'll talk about. But hopefully, and when it does represent the population, the statistic, the sample statistic will give us an idea of what the population statistic, the parameter, is like. All right, so let's we did the population and sample of the Instagram user. So what about the parameter and the statistic of this particular thing? I don't know if we actually have. So we don't actually have the data, but that doesn't mean we can't define it. So what is the parameter for this New York City food Instagram influencer question? And what is the statistic, guys?
The parameter is the average of all the influencers, and the statistic is the average of the ones that answered to the 68%. Very
good, right? So the parameter will be the proportion of all New York City followers, the influencers' followers, right? All of that. That will be that. And the statistic will be just the people who responded to the question, right? The data we actually have. Excellent. Very good job, Christina. Okay, so those are the two distinctions we want to have.
I have a question.
Yes.
So for that example, like the influencer in the New York City thing, so you said that the sample was the 68% that agreed with the influencer, but wouldn't it be everyone who responded?
Oh, I thought 68% did respond.
68% agreed with her.
I have confused about that too. Okay.
Yep.
Let's see. They asked their New York City followers to call a number and say the name of which restaurant they thought had the best pizza. It turned out 68% of callers agreed with the influencer choice. That's a very good point. Excellent. It would be everybody who responded.
Okay. And then so that means the statistic would be the average of everyone who responded.
Correct. Very good. Very good. This is very interesting, guys. I read that as 68% of the callers actually responded to that. But that's Samantha, that's a very good point. It should be all the data, as in all the people who actually did call in and gave an answer. Yes.
Okay, thank you.
Yeah, very good point.
How would you word that then?
I would word this as the statistic is the percentage of the callers who responded to the question that the influencer asked. Something like that. It's a long sentence, but you know what I mean. So it's not just agreed, but it's the people who responded to the call. Yes, it's a very good point. Let me just write this down. Example 5-2, callers who responded. I think the intention of the author who wrote this meant to say 68% out of the entire followers responded to the call. I think that's what I think that was the intention of the question, actually. But Samantha, that's a very good point. I'll contact the authors about this. All right. So the author wrote, I don't think this was an accurate reflection of all their New York City followers. Do you think all their New York City followers would actually spend money and also use their time to call up and voice a response to the survey? Why would you do that, right? I mean, yeah, nobody's gonna call and actually give up $1 to just make a vote, right? That's like kind of a ridiculous situation. But anyways, for the purpose of statistics. Okay. All right, so we have covered now parameter and statistic. Okay, so P with P, population with parameter, and whatchamacallit, sample with statistics. PPSS. Very good. All right, so now we're gonna go to chapter 6, and variables is gonna be our last topic before we do some kind of draw some charts and talk about some charts today, okay? All right, so let's go to chapter 6. I'll resume. This one you guys will be actually familiar with. Maybe you might not know the definition exactly, but you will, when you see the examples, you'll be quite familiar with what this is trying to say. All right. Carrie, could you start us off here?
Okay. Do you think everyone in this course has visited the same number of countries or have the same height or have the same favorite band or musical artist? Variability is one of the most fundamental principles of statistics. A variable is any characteristic of a person or thing that can be assigned a number or a category.
Very good. Okay, so variable is any characteristic of a person or thing. It doesn't always have to be a person. And it can be assigned a number or a category, right? So right here, if we call something a variable, it is not a constant. So in math, what you might immediately can relate to, maybe, when you think of, like, for example, when you draw a line on a coordinate system, we have y equals mx, right, guys? So you might have remembered that some of those things are variables, right? We can plug in numbers, and then some of them are constants, right? Meaning that it's a fixed number. So in y equals mx plus b, the m was the slope, and that's a constant, and plus b, that's the y-intercept, and that's a constant. That's always one number. But the x's and y's are variables, and we can plug in numbers into x, and as a result, we get a y. Or if we had a number for the y, then as a responding, we can calculate the x, and x and y's are variables. So that might be something that you might have heard of when you talk about variables, and then as opposed to constants, right? So variables can take in a number, right? It says it can be assigned a number or a category here. So in that y equals mx plus b, the x's and y's are assigned a number, okay? All right. Using statistics, we can draw a conclusion based on situations that vary, okay? In the definition of a variable, in particular, the people or things being observed are also referred to as observational units, okay? And this is something that we'll be practicing a little bit more in the Google spreadsheets. So our observational units are members of the group we wish to study. The variable is the specific property of the group that we are interested in. Okay, so let's try some examples together. Which of the following are variables that can be measured on those observational units, right? So there's hair color, whether or not a student has black hair, instructor's age, number of students with purple hair, height of shortest student in your class, and zip code from hometown. So what you need to ask yourself is if each of these is something that varies from student to student. So it shouldn't be a constant, right, guys? It shouldn't be always the same and doesn't change, but does it actually vary? Okay, so that's something that you'll be asking. So let's go to hair color. Imagine you make a list of all students and record for their hair color. Student 1 says brown, student 2 says black, somebody has purple hair, somebody has brown hair, somebody has blue hair, somebody has yellow hair. Is it changing, guys? Is it varying, or is it constant?
Varying.
It's varying. Therefore,
It's a
Therefore,
variable.
this is the variable, okay? Student's hair color is a variable. If I said Morgan's hair color, then even if you ask me, or even if you ask Mara, even if you ask Steffi, maybe we might differ a little bit because, you know, the way we see it, the color, but it's always gonna be quote unquote the same color. So in that case, it's not a variable, that will be a constant, okay? So hair color of each student, that's gonna be a variable, okay. Whether or not a student has black hair. Imagine you make a list of all students and record for each whether or not the student has black hair. For example, you might say student 1 says true, so maybe, oh, this is not corresponding to the one above. Okay, so it's different data. Student 1 says true, I do have black hair. Student 2 says true, me too. Student 3 says no, I do not have black hair. Student 4 says false, I do not have black hair. Is it varying or is it all the same, guys?
It's constant.
It's varying, right? True and false are not the same. So it's varying, and so this is also a variable. The fact is that we are only going to get two kinds of varying answers, right? It's either going to be true or false, but it's still not a constant. A constant will be always the same, okay? In this particular case, this is a very specific kind of variable, and this relates to what I do, you know, in computer science. True or false, when it's always between two options, we call that a binary variable. Bi as in two, right? So uni, like UNI, like uno, that's like for one. Bivariate, that's like BI, that's for two things. So bivariate as in two variables. And then we do multivariate, right? Multivariable, that's like many. But in this case, this is particularly a binary variable, okay? So that's a kind of a unique case. And that also exists as well. Okay, instructor's age. So let's pretend I'm 33. That's a sweet age to be, I guess. And I ask you, Samantha, how old am I? And they pretend you know it, and you're like 33. And I ask Morgan, how old am I? They say 33. All of the people say my age correctly, as assuming they're not trying to be facetious. So what do we see, guys? Is it constant or is it varying?
Constant.
Constant.
Very good. Every single student, if they're not trying to be tricky or whatever, should give you the same answer. So in this case, we are not looking at a variable. Okay, so this is not a variable. So that's all it is, right? Is something varying or is it not varying or is it all the same? Okay, number of students with purple hair. Apparently there was one person with purple hair in our class. So when I asked Liam and when I asked Emma, when I asked Joy, you all gave me the same answer, that one. So is it varying or is it constant?
Constant.
Constant. So this is not a variable. Okay, you're getting the gist of it? Very good. What about the height you see right here? Immediately. Variable or constant?
Variable.
Variable, right? It all is all changing. This is in a metric system, okay? Very good. Let's see. This is also involving a height, but we're saying that we are identifying the shortest student in the class. So even though no matter who you ask, you're going to get the same response. Kind of just like the instructor's age thing, right? And assuming that everybody does know the answer and gives you the right answer, right? It is not a variable. What about zip code? I'm going to ask you guys a zip code. Are you going to give me the same answers?
No.
No. Therefore, it is a
Variable.
variable. Very good. Okay, so this is kind of the variables we're talking about. Types of variables. This is, if you already see on the left side, 7.3 says binary variables. That is the one I was just talking about, where there's two choices, true or false. Okay, so you kind of got a little preview of that. So binary variables is one of the common variables that we do talk about. Types of variables, very quickly. There's quantitative variables. What do you think of when you hear this word quant?
Numbers.
Numbers, very good. So that's all it means. Variables that have numbers, right? So in the ones we looked at, like somebody's height. Oh, you don't see me, but I'm like clapping and moving around in my office because the light keeps going off. My office needs movement to have the light on. Okay, amount a customer spends in a store, percentage markup, all these things that has to do with numbers are quantitative variables. Anything that does not have to do with quant, we call them categorical variables, or sometimes we like to call it qualitative variables. But all you got to need to know is categorical, right? And so in this case, something to do with colors. So the different colors will be different categories, therefore categorical variables, right? We have a bunch of examples here: political affiliation, years in college, type of store, I guess online store versus brick and mortar store. I heard, I mean, not that they're really open, but I heard the brick and mortar stores are kind of coming back, especially in terms of fashion. Somebody was telling me how students like to go work for more brick and mortar places as opposed to big corporates like Macy's or Bloomingdale's and stuff like that. Is that true, guys? Possible? Maybe? No? Okay. Well, that's what a professor in the graduate school was telling me.
I feel like dependent on what field you're in, probably.
But then I forgot the name of it. So Macy's did this tricky thing where they opened up like a brand. I forget what it was. Maybe it was a shoe brand or whatever. But they have a new name for it, and it's all of these new things. And they never in their website or anywhere they say it's part of Macy's for this particular reason. So if you were just like visiting the site or an actual physical store, you would never know it's affiliated to Macy's. But this is to attract these younger generations who don't want to buy from Macy's or something like that. So apparently that's legal. So you don't have to say where you belong. So that's happening. All right. If you go to resume sharing, if you go to 7.4 other terms, I just said this, right? Another way to call categorical variables is qualitative data, right? It's qualitative as opposed to quantitative. So anything that is not quant, you can think of it as categorical qualitative. All right. So quant involves numbers. There's a bunch of examples that you can take a look at. So let's take a look at which one is quantitative versus categorical. I'll just do a few things. Whether or not the student went to sleep before midnight. What are the possible answers, guys?
Yes or no?
Yes or no?
No. So therefore, what is it?
Binary.
Categorical.
Oh, binary. Yeah. It would be
It is
true.
categorical, correct, right? Because it has two categories, right? But in particular, it's a specific variable called binary, okay? Categorical is still correct. Very good, right? It's not quantitative, though. Very good. All right, what about distance from where a student calls home?
Quantitative.
This one right here. Who said that?
Quantitative.
Quantitative, right? The distance is a measure of length, that's going to be in numbers, right? How many email messages student has sent in the last 24 hours?
Quantitative.
How many emails have you guys sent in the last 24 hours, guys? I bet I can beat you. 3? That's not bad. I think I've sent over 20. It's insane. This happens. It happened in the beginning of the year. All right, so pretty clear, right? If it involves numbers, it's quantitative. If not, categorical. In particular, if it deals with two categories, then we know it's a binary variable, okay? And variable meaning it varies. Things are changing. It's not a constant, okay? And then don't forget, where is it? Do I go up to here? What is a variable? Is it a variable here? Just don't forget this observational units, okay? The definition. The people or things being observed are also referred to as observational units, okay? So those are just a few things you need to know. Remember, all of this material will be available for you during the exams and all the things that you do, like problem sets and whatnot, okay? So, I mean, it is the basic concept like mu and X bar and parameter versus statistic. You should know and like memorize it, but don't like feel that enormous pressure that you need to memorize all of this, right? As long as you're following along and understanding and getting the distinction, you're at a pretty good place. Because by the time we get to like an exam, you have repeated this so many times that you will fundamentally really understand it in and out, okay? All right, so even though it's going a little bit quickly, I'm telling you just not to worry about it too much, okay? All right, so we're going to skip chapter 8, validity and reliability, just because of the time constraint, and we could come back to it later. But let's go to chapter 9 and 10, and that's the last topic we're going to do. And this time we're going to actually go into Google Spreadsheets and draw some of these charts, okay? So we have some experience dealing with Google Spreadsheets, okay? All right, so let's go to the last part. Let's go to dot plots. People seen dot plots before? It's kind of interesting looking. All right, Naja, could you start us in chapter 9? Dot plots are.
Dot plots are visual representations of a set of data. They show the data in a set of they show the data values in a set of data as stacks of dots according to how many data values there are. They are very simple, so they are very easy to interpret. If your data set is very big, though, they can become cluttered.
Right, so this is for kind of like smaller data sets to kind of look at it right away. So if you scroll down and see example 1, we have 1, 2, 3, 4, 5, 6, 7 numbers. 7 numbers right here, and then we're going to make that into a dot plot. It literally has dots in it. That's why it's called a dot plot, right? These names are actually named, so it's supposedly because it makes sense and doesn't confuse you, right? So you'll see 1 unit is 5, so we put a dot right there. And so you can see on the y-axis, this is the frequency, right? 1, 2, 3, 4. How many times has it appeared? The frequency. The number 5 appeared once, so that's where you put the dot. And then up here, you'll see 6 here, and 6 here, you see it twice. So you put a 1 here, and you put another dot there. So there's 2 times you see 6. And the same goes for 8 and 9. And so that's how dot plots work, okay? So very quickly, kind of just like looking at this from far away, you're like, so 8 appears the most frequently. You can see that without having to, and looking at, a list of numbers like it is above here, immediately you might not see that, right? You kind of have to pay more attention, but that's the whole point about these graphs, is that immediately at like your first kind of view and glance at it, you can kind of see what's there. And that's the whole point of dot plots, okay?
But this is for like really, really, really small data.
Yes.
This is like you have like, okay. All right.
Yeah, I mean, it can get up to, depending on what you want to have on the x-axis and y-axis, it could have like, I don't know, I'm gonna like probably just say some random number. It could have like 100, maybe 100 data entries, and you can kind of plot it. But maybe you have to zoom out quite a bit or something like that. Excuse me, but it is meant to deal with smaller data sets for sure. Yes, absolutely. Okay.
Will dot be described as more than 1 unit? Like 1 dot is 5 units. So if you're considering a large group of data, you can do. Do they do that?
Repeat. So do they do as in like if we have? So like you said, 5 units for
1 dot. Just to analyze a larger group. Do they do that? I'm just kidding.
So in this particular case, if we saw the number 5 times, then the dot will be stacked, and there'll be 5 of those. Okay.
Oh, okay. So we're numerical. Yes, I get it.
But at any like kind of like Morgan was saying, if we get to like a bigger data set, this is probably not going to be our default choice in terms of visually representing the data.
A dot plot is separate from a scatter plot, right? Like they're not the same.
Correct. They're different. They're different. Yes. They're different. Yes. Very good. Because anyways, we'll get to that, but dot plot is just like exactly what you see. Very simple. It just literally kind of stacks all the data points. So basically, if your kind of paper or your screen allows, you should be able to see every data entry on the graph in a dot plot. Okay? All right. So we're going to talk about 3 important properties in the dot plot. There's going to be peaks, and it sounds exactly what it sounds like. There's the peaks. So these are like peaks, 2 peaks right here. So we're going to go up and see. So this is a bigger data set, but still very, very small. And if you see this list, you're like, oh my God, that's so many numbers. And I'm like, I don't know where the commas are. It's kind of confusing, right? So this is exactly when a graphical representation would be easier to digest. Oh, I am not sharing right now. So then, and then you can graph it like this. So from a first glance of this, all these numbers listed, I don't really know, but if you look closely, there's 4, 4, 4, 4. So 4 appears 4 times. So literally 1, 2, 3, 4, you have these 4 dots where 4 is, right? And then apparently that happens the same for 12. So in this case, we have 2 peaks, okay? So peaks is something that we look at when we look at dot plots, kind of see where the highest frequency is. And then distribution, this particular one, every one of these numbers, whatever they are, there's only an occurrence of 1. It only happens once for each one, right? So this is kind of like a distribution with no peaks, as opposed to something with 2 peaks over here, okay? So there could be different things like that. Sometimes we describe peaks as clusters sometimes. That's another way to describe it. But you can have clustering without a peak. Let's see if there's an example of that. Like they're clustered here, right? These dots are clustered in this area, and there's a cluster here in this area, but there's no peaks, right? So this can happen as well. So there's all kinds of different variations and examples of how the dot plot might look. So some of the things that we look at is the spread. Spread is the second thing. And earlier we talked about peaks, okay? One common way to talk about the spread is looking at the range. You might have heard of this particular word, right? And the range usually covers from the minimum all the way to the maximum, right? So you can see that the spread is going from, for this one, something like, I think it's 20 all the way to 37. That's going to be the range of this particular dot plot. Okay? Sometimes a range will give you like really important information. Let's say, for that pizza influencer IG guy, you wanted to see who the youngest demographic he has as a follower and who's the oldest. So the range will tell you that. Maybe he has followers starting from like 8 years old all the way to 65 or something like that. Then he knows that he has a big range of people who is following him. But maybe it's more like 22 to 32, then he has a shorter range, so not as big of a spread of followers to his Instagram account, okay? And then, last but not least, outliers. Who remembers what outliers are? I think this might have been, we kind of talk about this colloquially too, I would say, at times. Without really defining it, can anybody tell me what the outliers might be in this particular dot plot?
It's the 24 and the
25 and 27.
27.
25 and maybe 27, right? Basically, out of the kind of common area, if you will, right? Where most of the data points are. That's called an outlier, right? So very good, right? These are the data values that are far from the others in the data. And so you might ask, well, how far are you talking? And that also kind of depends on what you're looking at, right? So it depends on how you define where all the data points are. Like maybe, I mean, in this case, it's a little bit more obvious, but maybe you also will consider some of these dots. I guess this won't really be. But depending on what your research question is, the outliers could be defined a little bit differently. Most of the time, it should be quite clear to almost anybody, but it could be a little bit, it could vary a little bit too, okay? All right, so this is kind of one example. You might describe the outliers as 25 and 27, right? Also, there are a couple of clusters of high values as well around 58 and 62. So these are just kind of like the clusters we're talking about. These might not be considered outliers. As here it says, you would definitely like to understand what is happening there as well, right? So depending on what you're looking at, Some things that you might not consider as outliers could become outliers too, okay? You don't need to go into so much depth into like how to define an outlier too much, except that usually it's some of the data values that are far away from the general group of all the data points, okay? That's as far as you really need to know. All right. Now we're going to talk about bar plots, and we're going to draw some, okay? So bar plots, as you might imagine, it has all these bars, okay? So let's go ahead, instead of kind of reading all of this, and the bar plots are also going to involve like percentages and stuff, why don't we do something together, okay? So I'll pause my share just for now. Let's all go to Blackboard, and in this case, go to Content, and then go to number 2, Parameters, Statistics, and Variables. That's what we did today, okay? So we're gonna go to, I think it's in, so there's mod 2 question assignment. I don't think it's that one. Go to mod 2 spreadsheet assignment, bar chart. So click on that one. So if you click on it, you're gonna be sent to basically an Excel sheet, but like a Google spreadsheet. And I think you only have view access. So go to File, and then go to Make a Copy. Copy this one, okay? And then you'll name it whatever you want. And then from there, once everybody's done that, then we'll do some bar plots together. Okay? So just ping me in the chat if you're ready to go. You made a copy and I'm ready to make a bar chart. Just tell me that, okay?
Is this the mod 2 questions, or is it the mod 2 spreadsheet assignment bar chart?
The spreadsheet assignment, the second one.
Okay.
Yeah. And for those of you guys who, we'll do this together, but if you want to kind of look for some written descriptions, right above the mod 2 spreadsheet assignment bar chart, there's a mod 2 spreadsheet tutorial. That's going to basically walk you through all the steps that I'm about to do and do with you guys, okay? So you can open that up as well if you want to follow along with that. But anyways, I will give you some demonstration on how to do that, okay? Some of you guys already might know how to do this. All right, let's see. Carrie's ready, Samantha's ready, Amanda's ready, Emily's ready, Abby's ready, Morgan's ready, Liam's ready. Okay, Alexa's ready, Deirdre's ready, Polina's ready. Good, 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 good. Okay, great. All right, so let me make sure I'm sharing my screen first.
Mine is on view only, but I requested an edit access. But I don't know if
so make sure if everything is going to be view only when you first open it. So then you have to go to File and then Make a Copy. This is always going to be the case with Google Spreadsheet, because I don't want you guys to kind of type in my copy, so you should make your own copy.
Oh.
Yep. Yeah, so that is the default. You should not have access to edit it, just viewing privileges. Okay, and I actually will make a copy too, so I keep this original thing. Make a copy, like in class. Name it whatever you want, and maybe you want to put it in a particular folder in your drive. If you want to do that, go ahead and do that as well, okay? If you don't want to, you don't have to as well.
Do we share it with you?
Not yet.
Okay.
Let's share it with me after we're done, okay?
Okay.
But yes, I will require you to share it with me, guys. Share it with me. Okay, so everybody sees my screen. You guys see the spreadsheet here?
Yeah.
Okay, perfect. All right, so we have a little bit of information right here. We have company, we have sales. Apparently a pop shop has this much sales, and Tommy Go Figure, Never 42, country, and fitters is the names I chose. Okay, so what we're going to do is we're going to make a bar chart. So for example, not for example, we're going to click on A2, and then you're going to select all of these cells, including the company and sales, all of them, including the titles of them as well. Okay, you got that? So make sure it will usually be like this blue color. You select all of that, and then you're going to go to Insert, and you're going to go to chart. And then by default, this pie chart might appear, and that's fine. You're going to have this pop-up window right here that has says chart editor. Instead of pie chart, make sure my lights are on in my room. Instead of pie chart, there's going to be a drop-down menu, and you're going to go to this particular one right here. That says column chart. This is basically a bar chart, okay? They're just kind of naming it something different. So if you click on that, immediately you're going to see a bar chart. So it says sales versus company. And then you see here for your column A becomes by default the x-axis. So you have the name of the different companies. And then on the y-axis, you have the sales, okay? That's because it was in that order. If sales was on a column A, then that probably would have been on the x-axis, okay? And you can switch those around if you want to. Okay, so immediately we have a, I'm trying to move this. Oh, here we go. If you grab it with a hand, you can like move it around. Okay, so immediately we have a bar chart right here. So immediately you can see, and maybe that because there was only 4 cells, it was easy to see on the cells here too. But you will see here that Never 42 had the highest sales. Okay, we all made those bar charts. Quite simple, right?
Yeah.
All right. Now what we're going to do is that sometimes these raw numbers are important too, but really more than anything, we might want to see the percentage of this, okay? So let's go ahead and calculate the percentage of this. All right, so what we're going to do is we're going to make a third column right here, and maybe you can put in the word percent in there, okay? If you want to actually make it the same, bold it, and I don't know, to the side, I guess the make all the things look the same thing. Okay, so I'm putting the percent in here. And so this is where we're going to use those formulas and stuff where you're going to make sure that the calculation, you don't have to do it yourself, but Google Spreadsheet will do it for you, okay? So anytime, and some of you guys have done a lot of work in Excel, so this is going to be very, very easy for you. But what you're going to do here is that you're going to make an equal sign right here. Equal sign is always the beginning of putting in some kind of mathematical formula in there, okay? And then you're going to select, actually, before we do that, let's actually make a little cell right here that says total. Okay, and what I'm going to do is that here I'm going to get the total of all of it. So here I'm going to make an equal sign, and then I'm going to click on this, and then you can, and this is where the formula is being formed, and you can put a plus sign in here and click on the next one, plus sign, click on the next one, plus sign, click on the next one. Okay, once you're done, you're going to hit enter, and then it will automatically do all the addition for you. And you see if you click on that cell, the initial formula you used is right there. And so you can always refer back to it. You can always edit it. Okay? I don't know if I like this font. I'm just a little OCD sometimes. I don't like any of them. Okay, I'll stick to this. Okay. All right, so the total is right here. The reason why we have total is because when we calculate the percentage, everything is going to be out of the total. That's how you calculate percentage, right? So we needed this in order to calculate the percentages. And that's why I went back and was like, let's do the percentages first, okay? All right, so now we're going to do equal right here. And then we're going to click on this, whatever it is of Pop Shop, divided, and you use this kind of slash right here, divided by this total amount, which is B7, okay? And then when you hit enter, it's going to create the percentage for you, right? I don't know if you guys see a number here or if you see a percentage, but after we fill in all the cells, I'll tell you how you can switch to a number, switch all of them to numbers or switch all of them to percentages, okay? Again, okay? So right now we do this, and what we want to do, and this is a nice thing to do in Excel as well as the spreadsheet, is we don't want to do this for every cell. We don't want to do equal this divided by this. We want, we don't want to repeat that because that's too many. Right now it's only 4 cells, but what if we had 100 lines? We don't want to do that 100 times, right? That defeats the purpose. So we're going to try to make the spreadsheet do this automatically. So what you're going to do is, I'm going to click on this. And so if you're on a PC, you are going to try to do, I believe it's like function and then F4 key. If you're on a Mac, try Command and then T. Oh, oops, that wasn't it. That was opening a new tab. That's right. Maybe I did that wrong. Okay. For this one, let me try that. Command T. Did that work? No, that didn't work. Okay, so let's just manually do it. I forgot the short keys, I guess. So what you're going to do is in front of the B, you're going to put a $sign in there. And then in front of the 7, you're going to put a $sign in there. Okay? So now instead of just B7, you have $sign B, $sign 7. Okay? What this is going to do, because there is this feature where you can drag down and apply the same formula to all the cells. What this is going to allow you to do is that this bottom thing is not going to change as you go down. It's going to always be the same number, B7. So it's kind of putting an anchor there if you want, if you will, okay? So if you go back and click on that cell, the first pop shop, you're going to see a little square at the end, at the, what is it, right, what am I saying? Bottom right. So you're gonna put your little cursor there, and then it's gonna turn into a cross sign, and then you're gonna drag that down all the way to country in fitters. And there you go. And what it did was, if you actually click on the cells, you will be able to see the formula. And it says B4, which is this one, Tommy go figure, and then it's divided by the B7. And then if you go to Never 42, it's, you can see, click on this, and it's B5 divided by B7. And then if you go to this one, you know that's B6 divided by B7, right? So as it went down and applied that formula, always the denominator stayed in the same place, or referred to the same cell, if you will. Okay, so that's what happened there. Yes, questions?
So for the $sign, do we have to put that in every time we want to drag it down? Because I tried dragging it down before the $sign and it didn't work.
Exactly. That's why we put the $sign in it, because it's not recognizing what it has to divide it by. And so the $sign is anchoring it to make sure that always this particular cell is referred to when it has the command to divide it by. So yes, if that's the percentage, if you're calculating percentage, yes, you have to put the $sign in. If we're dealing with other things, for example, sometimes I take attendance of you guys, right? Like, look at this. And then I want to say yes, right? And then I want to say next one, yes. If I want everybody to be yes, I can do this and I'll drag it down and it's going to fill up yes for me, right? In this case, I didn't have to anchor anything, right? It just knew that by this command, I'm repeating the same thing over and over, okay? But that's not the case. In this particular case, we're actually doing some kind of calculation, and not any kind of calculation. We're always dividing by the total. So that's why we needed these particular anchoring tools, if you will, which is done by that $sign. Okay?
Okay, thank you.
Yeah, great question.
And it still didn't work.
It doesn't work?
Yeah, it says
Okay.
like.
So what I like to do in these cases, why don't you go ahead and share your screen with us, and then we can help you see what's going on.
How should I share? Oh, I see.
If you go to the bottom of the Zoom thing, there is a little thing that says screen share. The Zoom window.
Yeah.
Yeah, and then you share your screen, and then I should be able to see it in a second. Maybe I have to stop sharing. Maybe that's how it's gonna work. I hear somebody saying hello.
Oh, okay. Can you hear me? You can hear me? Okay.
I can hear you very tiny. Who's talking?
Morgan?
Oh, Morgan, okay.
I'm not sure what happened. I was just asking, what was the shortcut again for the fixed cell reference?
The shortcut, what are you, a PC or a Mac? PC. So try when you do like say cell B3 divided by B7. Then try function and then F4.
Okay, got it. Yeah.
Does it work? Okay, perfect. Then that is working. Yeah. So Christina, there you go. I see it. Okay. So, okay, remember, I see it immediately. So you see where your cell is, it says $B, but there's no $sign in front of the 7. Yeah. And then on the top, on the numerator, there should not be a $sign in front of the B3.
Gotcha.
Yes. Okay. So now do enter. Now to enter, good. And then go back to that cell. And then, yeah, that little square thing. There you go. And drag it down. Beautiful. There you go. Got it? Okay.
Yeah.
So it's the $sign only in the denominator, and it's in front of the letter, and then it's in front of the number. So if any of you guys were having the same issue, that's what was happening. And then share my screen again. All right. So then now we have also to enter. Oh, click on. Okay. Now we do enter. So mine automatically did percentages, but you can go ahead and select these things. And if it were not in percentages right away, then you can go to, I believe it was maybe format, and then go to number. Yeah. So if you go to number, because mine is in percent now, then all of it will turn into a number. But if you have numbers, let's go ahead and actually change it to percentage. So go to format and then go to number, and then you can click on percentage. And then that's what we want. Oh, and I guess right now it automatically gives me 2 decimal points, which is fine. Okay. So now we're going to create another bar chart, but this time we're going to involve the percentages and not the actual raw numbers of the sales. Okay. So in order to do that, what you're going to do is you're going to select company and then up to country in fitters. And I believe on a PC, it's probably control. And on a Mac, it's probably command. So click on command and then go to percent. And then, something happened. Let's see, let me try that again. I'm on a Mac right now. So I think I'm going to do command and then select these things. And so then you can select those 2 columns. Try it with control if you're a PC. I think it's control key. You hold down the control key and then you add the C2 all the way to C6 to your selection. And I believe it's the command key on the Mac. So then you'll have, not including the sales, you'll have the company highlighted and the percentage highlighted. Okay, so if you're with me, then we're going to go back to insert, and then we're going to go to chart. And this time, I guess because earlier I chose column chart, it's choosing column chart by default. And as you can see, like the one right next to me, instead of, so this is basically the same chart, right? But this one has the raw numbers, the raw sales numbers, which is probably in dollars, but this one has percentages out of the total. So out of all of these 1, 2, 3, 4 companies, Never 42 made 50% in the sales of the total sales that were made. Everybody is up to this point? So you should have one bar chart. For me, that's on my right side.
How did you create the other bar chart after selecting the 2 columns?
So how did I make this one? The percentage one?
Yeah, because...
so if you get a pie chart by default, so what I did was after I selected it, I went to insert, and I chose chart, and then this this chart editor is going to pop up, and it might be that your chart type is set to pie chart. If that's the case, then do the drop down button and make sure you select the in Google Spreadsheet they call it the column chart. which is basically equivalent to bar chart. You know, a bar or a column, they're basically the same concept.
So
that's-
I tried to, my first bar chart came out with all of the companies, and then for the second one, only 3 of them came, and I had them all highlighted when I tried to make the bar chart. So I don't know
Yeah,
what
that
I'm doing
happened to
wrong.
me too.
Oh, really? Okay. Weird. Is it by any chance that your screen is like kind of condensed, so you drag out your what's it called, your a chart, and see if it's hiding behind something?
I tried to do that.
No, yeah, it's
No,
not.
I figured it out. What you
What
have
is
to
it?
do is put data range, like that's under the chart type, and then you have to put in A6 and C6.
Oh, okay.
Oh, so
A6
somehow it didn't get selected.
Could you demonstrate how to make that second chart one more time? Just because like I'm struggling to select just the company and the percentage.
Sure. Okay, let me go back to resume sharing. So I just deleted mine just for that purpose, and let me just get rid of this as well, so it's just not distracting you. So somehow my like scroll thing is not working. So what I did was I did this, and then with I'm on a Mac, so I did Shift and did this. That will be the same on a PC. And then what I did was so either press Control if you're on a Windows, and if you're on a Mac like I am, then press Command. And what I did was I just selected individual and then added to it. Somehow my dragging thing wasn't really working, so that's how I selected everything. Did you get that, Emma?
Yep.
Okay, so now after that, you're going to go to Insert, then you're going to go to Chart. And then if you're like me and the pie chart is by default there, then you're going to go to the chart type and click on the drop down and go to the column chart, which is going to give you this. If for some reason one of your bars are not showing up, like some of you guys are saying, a solution to that is if you go a little bit down here where my cursor is, there's a data range, and this should be at the right place, A2 to A6, as well as C2 to C6. Okay, and so for some reason, I mean, it should work for everybody, but the data range is correct, so it's showing everything. For those of you guys who were not showing all of them, maybe this was A5 and this was C5, just switch that to A6 and C6 and you should be fine.
Okay, got it.
Awesome. All right. Any more questions?
Professor, why would you ever use a bar chart to show percentages? Okay, not like that, but like
why would you not like it?
No, I mean like, but why wouldn't you use a pie chart? Because it like, you know, like visually it's a lot better.
Well, that's like saying like, I'm a numbers person, and you're like, why would you ever use numbers? Like, put it in text, right? It's just a preference.
Okay, gotcha. I was just, because like it already has the total for you, because like we didn't like doing all those calculations or whatever. Like if you would have just done the chart, it like split it up. Like the pie chart already had those.
Yeah. I mean, it's just a preference thing. I mean, there's some things, and we'll deal with a lot more things. Some people are much better at processing different things. Some people prefer different kind of shapes and colors and different things. I personally don't like pie charts. To me, it's not very obvious. I actually think the bar charts are better. So I'm a classic example of why you would do this. Somehow pie charts are very confusing to me. But it doesn't have to be. Obviously, pie charts are obvious to other people. Like to me, bar charts are clear. Dot plots I hate. I never understood dot plots really. There's also box and whisker charts, and there's all these different things, and people have all kinds of strong preferences and proclivities about it. I'm like, oh, I hate these charts. That's fine. You can hate on charts. I don't think anybody will be very angry about that. It's just a preference thing. There are, I have to say though, there are certain charts that I think will convey things much better than other things. And I'll show you, maybe not today, but I'll show you a beautiful visualization, an interactive visualization of data. Maybe I can do that next week or something, or when we do misuses of statistics, where some very different kinds of mechanisms are used to describe data. And I think some of them are done very nicely. But at the same time, Morgan, you might hate what they did too, right? So it's just a preference. I love how you're like, why would you ever use this? I'm like,
No, like it makes sense, but I was just saying, like, I don't know, from like we went through so much work to get exactly what we could have gotten just by clicking pie chart, you know?
yeah, I guess, yeah.
But like you don't like pie charts, so it's totally fine. That's okay.
I love that my hatred towards this particular thing is not controversial. You know what I mean? Like, it's fine. Okay. So yeah, you can do a pie chart if you want to, as long as I say that's fine. But if the instruction says bar plots, then do the bar charts, okay? So that's all it is. So one thing I'll share right now. So this is what I want everybody to do, and I'm going to check my email right away before you leave, because this is part of the participation. Go ahead and go to File, everybody, and then go to Share. Or you don't have to do it that way. You can do a share over here, right? And everybody's going to type in my name, Maria_Huang at FIT-NewYorkCity.edu. Okay? So go ahead and click on that, and then you're going to notify people. That's going to be automatically, and then you're just going to send that to me right now. Okay? And I'm going to check my email so that I see that every one of you guys actually have done that, so that I know. Okay. Lights keep turning off. Okay, so I'm going to go to my email. I'm going to check everybody who's sharing it with me, okay? So then that particular assignment is done in class, so you don't have to worry about it. As long as I get an email from you, that means you're done. And I should start, ooh, look at that. All of a sudden, huge amount of people. Let's see, I got it from Carrie, Christina, Steffi, Akili, Samantha, Deidre, Emily. Got it from Alexis, James Lynn, Jenny, Abby, Naja, Ashley, Emma, Savannah, Morgan, Joy, and Liam. Anybody who shared it with me, but I didn't call the name out? Let me refresh. And Paulina just sent it in. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
So do we just have to worry about the first assignment then? The one about...
Yes. Okay, so let me talk about that, and then I'll let you guys go, okay? All right, so let me go to resume share. Let's see how this works. So if this is going to work, I might. Okay, so this is what you need to do, guys, for next week, okay? You are going to go to, first of all, Introduction to Statistics. This is the very first one. You are going to go to Mod Question Assignment 1. I think we actually opened it up together. And then you'll see this. And there should be 3 example sheets. Example 1, example 2, example 3. Very simple. It's just identifying population versus sample, okay? So remember, again, you're going to go to File, and you're going to make a copy. And so then you have your own copy, and then you're going to fill in the answers. And at the end of it, let me just see if this works. Print. Okay, good. So this is what I want you to do, guys. I'll make a place where you can submit it, because I can't, I have a lot of sections and I can't, everybody's going to be sharing this with me at a different time. So it's going to be very messy to actually check all of this. So what I'm going to ask you guys, unless I make you share it with me in class at that particular moment, anything else is what you're going to do. You're going to go to, let's say you finished it and there's like answer all the way here. What you're going to go to is you're going to go to File, and you're going to go and click on Print. But you're not actually going to print it, okay, guys? You're going to go on Print. You might have done this before. And instead of the paper size, oh, is it not there? Was it Workbook? Oh, I thought there was a way to do PDF.
You can go to File, Save as a PDF in Google.
Oh, because this is a Google spreadsheet, not Google, not coding. Okay, so then you can do, maybe it's download as a PDF, or let's do download as an Excel sheet, since it is most similar to Excel. You're gonna go ahead and download that with all your answers, and then I'm gonna have you submit it on Blackboard, okay? So I will make a place right here. If you see, I'm gonna do assessment, and I'm gonna do assignment, and I will have a place where it says Mod 1 question submission, and then you're gonna submit it right there, okay? And then this is just introduction to spreadsheets, so you don't have to do anything. You can just open it up and look it up, and that's it. That's all you have to do. So Mod 1 questions, that's what you have to submit. I'm gonna make the submission page right after this. And then go to content and go to question 2. So you don't have to worry about the mod
different. The mod 1 question is different for me. I mean, the paragraph is different.
Are you sure? So there's 3 sheets inside it, an example 1, example 2, and example 3. So maybe you're on a different sheet. The first one should be Michael Jackson, and then it's gun control, and then it's Landon versus Roosevelt.
Oh, okay. So it's the Michael Jackson one. Okay.
Yeah. So there's 3 sheets there. Okay, so make sure you're doing 3 of those. And the next one is going to be mod 2 question assignment. Okay, so you're going to click on that. Again, you're going to go to File and save a copy for yourself. And you're going to see that there's 6 example sheets on the bottom. Some of them are going to be very quick, right? What's the number of words? What's a this? It's just very briefly, just kind of identifying different things. And you'll see that some of them are going to be about parameter versus statistic. Some things are going to be about variables, like what kind of variable is it? Is it a categorical variable, a binary variable? Easy. And then we're going to draw 1 dot plot. And then we're going to do what we did here, just like the bar charts and the percentages and stuff like that. So when you're done with that, you're going to file and download as a Microsoft Excel sheet. And then I don't have it now, but there's going to be a place where it says mod 2 question assignment submission, and you're going to submit it right there. Okay, so those are the Google spreadsheet things. And then remember, you're going to go to then MA222 Lumen, and then you're going to finish problem set 1. And I'll make sure that you have multiple attempts to do this. Okay, so for 3 things, right? 2 Google spreadsheet things, mod 1 and mod 2, and then problem set 1. Those are the things that we're doing. All right, everybody clear?
Are these all due Monday?
These are due Monday. Let's say Monday at about 11 a.m. because we start at 12:10, okay? Or even maybe.
Where did you find mod 2? Is it still under Introduction to Statistics?
No, it's the next content. So if you look at the titles, it is according to the it says variable, so go to content. And then it's 2 parameters, statistics, variables. That's what we covered today. And so mod 2 is going to be in there.
Do we still have classes
on
Monday because of Labor Day weekend?
Oh, thank you. Is Monday Labor Day?
Yeah.
Oh, okay. Then you have till Wednesday, guys.
Okay. Cool.
Cool. Look at that. Who said that? Was it Emma? Good for you. Everybody think Emma. Be like, yay. There's a little button in Zoom where you can do a thumbs up or clapping things in your little thing. Anyways, you'll learn about it. Okay, so that's it. Then I'll see you on Wednesday instead of Monday. Great reminder. All right, we're all good?
Yes, thank you.
Good? All right, guys. Have a great weekend.
Thank you.
Thank you.
Bye-bye. Stop recording.